Massive. Astronomers using JWST may have discovered the first black hole star ever. Black holes are one of the scariest things in our universe. They're basically regions of space-time where gravity is so strong that nothing can escape, not even light. And because they don't emit any light themselves, the only way we can detect them is by observing the effects they have on other objects. Black holes come in a variety of sizes, but the largest ones are supermassive black holes, which can be millions or even billions of times the mass of our Sun. These giants reside at the center of most galaxies, including our own Milky Way. And while they're typically pretty inactive, occasionally they do something amazing. Sometimes they spit out huge jets of material that extend for thousands of light years, covering enormous distances. But here's the thing. Astronomers using the James Webb Space Telescope recently observed a strange object that appears to be a black hole with an actual star orbiting around it. This discovery could revolutionize our understanding of these mysterious phenomena. Now let's talk about this crazy discovery and all the latest updates in this research. First off, what is a black hole star? It's a term used to describe a very specific type of binary system. A binary system is just two objects that orbit each other, like a pair of stars. But in a black hole star, one of those objects is a black hole. So a star is literally going around a region of space from which nothing can escape. The idea is wild, but it's actually been predicted by Einstein's theory of general relativity. According to this theory, anything with mass distorts space-time around it, and when something else comes along, it just follows the curves of this space-time. So if a star gets too close to a black hole, it won't fall into it immediately. Instead, it will start orbiting around it. However, there are some conditions for this to happen. The star has to be big enough, and it also needs to be far enough away. If it's too small or too close, it will get pulled into the black hole. So what makes this new discovery so exciting? Well, up until now, astronomers have only ever seen the light coming from the stuff around black holes. It's never actually captured the light emitted by the star itself. In most cases, the star is just too far away to observe. But with the James Webb Telescope, astronomers think they may finally have a chance to study these systems up close. In fact, researchers believe that they have already found several candidates for black hole stars, and one of the most promising is called HR 6819. Located in the constellation of Volans, this system is about 1,000 light-years away from Earth, and its distance is why astronomers are hesitantly excited about it. With the James Webb Telescope, they can measure the speed of the star in the system, and then use that to estimate its mass. If the star is massive enough, it could be a black hole star. And to do that, they need to determine the speed of the star by looking at how fast it moves back and forth as it orbits around something invisible. And it's not easy. To figure out how fast something is moving, astronomers use something called the Doppler effect. You see, when an object moves towards us, the light it emits gets compressed, which shifts the wavelengths of the light towards the blue end of the spectrum. This is called blue shift. On the other hand, if the object is moving away from us, the light gets stretched out, which shifts the wavelengths towards the red end of the spectrum. This is called redshift. By measuring the degree of shift in the wavelengths, astronomers can calculate the object's velocity. However, there's a problem. They can only measure the component of the velocity that is along our line of sight. To get the total velocity, they need to know the angle between their line of sight and the orbital axis of the system. And figuring that out is not easy. But astronomers have developed a few clever ways to do it. One is to look at the light from the star in different wavelengths and see how much each wavelength is shifted. That can tell us both the radial velocity of the star and the angle of the orbital axis. Another method is to watch the star as it moves around and measure the changes in its brightness. This is called the light curve of the system. By analyzing the shape of the light curve, astronomers can infer the inclination of the orbit, and thus the total velocity of the star. These methods have been used to study a number of potential black hole stars, and one of the most interesting candidates is HR 6819. This system was first identified in 2020. and it was a bit controversial because some astronomers argued that it might not actually be a binary system at all. They suggested that the two objects might be physically connected in some way, like a trinary system or a quadruple system. However, a study published in 2023 provided strong evidence that it is indeed a binary system. The researchers used the European Southern Observatory's Very Large Telescope to observe HR 6819, and they were able to detect both objects clearly. They also measured the radial velocity of the system and estimated the mass of the invisible object to be more than 10 times the mass of the Sun. This is right in the range for a black hole, but it could also be a very massive neutron star. Now, you might be wondering, what's the difference between a black hole and a neutron star? Well, both are incredibly dense, but they're formed in different ways. Neutron stars form when a single star collapses at the end of its life, while black holes form when multiple stars collapse together. Technically speaking, a neutron star is the final stage of a high-mass star, while a black hole is the final stage of a supermassive star. Also, a black hole is an irreversible process, meaning once something crosses the event horizon, not even light can escape. On the other hand, a neutron star can bounce back if something tries to cross its surface. So, theoretically, there should be no such thing as a black hole star. However, in practice, it's possible that some neutron stars could be so massive that they appear similar to black holes from far away. This is because they both have strong gravitational fields and don't emit any light, so they can be hard to distinguish. Therefore, astronomers are still investigating HR 6819 to determine whether the invisible object is a black hole or a neutron star. This will help them better understand the formation and evolution of these extreme objects. One of the ways they are doing this is by using the James Webb Telescope to look at the light coming from the star in the system. By studying the spectrum of the light, astronomers can look for signs of blue shift and red shift, and use that to calculate the star's velocity. With this information, they can estimate the mass of the invisible object and get a better sense of what it is. Additionally, the James Webb Telescope is powerful enough to detect the heat coming off the star, which will provide valuable insights into its size and temperature. All of this data will help astronomers piece together the puzzle of HR 6819 and figure out whether it is indeed a black hole star. If it is, it would be a major breakthrough for astronomy and astrophysics. Not only would it confirm the existence of these long-theorized objects, but it would also open up a whole new window into the study of black holes. For example, by observing the light coming from the star, astronomers could study the accretion disk around the black hole and learn more about how matter behaves under such extreme conditions. They could also use the star as a probe to study the gravitational field around the black hole and test Einstein's theory of general relativity. Of course, there are also some challenges associated with this research. For example, because HR 6819 is relatively far away, it is very difficult to collect enough data to make precise measurements. The star is also very faint, which makes it challenging to detect its light through the glare of the black hole. Nevertheless, the James Webb Telescope is up for the task, and astronomers are eager to see what data it can collect. In conclusion, the James Webb Telescope has revolutionized our understanding of the universe, and its capabilities are only becoming more apparent. The potential discovery of the first black hole star would be a monumental achievement for astronomy and astrophysics. By studying these extreme objects, astronomers can learn more about the fundamental laws of physics and the nature of the universe itself. The James Webb Telescope is up for the challenge, and we eagerly await its findings. What do you guys think? Let me know your thoughts. Thanks for watching. Subscribe for more videos like this, and I'll see you in the next video.